All right, so some quick practice problems to make sure we're all on the same page. It says use the equation below to answer questions 1 through 3. Question number 1 says state completely what is happening in the reaction given above. Include in your answer the physical states of each component of the reaction. So again, it's really important that you're able to translate sort of what's happening at the macroscopic level to a chemical equation, and vice versa. So can you look at a chemical equation and translate it to sort of what would have happened in the macroscopic world? So here we go. Number 1, we're going to simply write in this reaction. Let's take a look at our first reactant. We've got 1 mole of aqueous sodium carbonate reacts with 2 moles of aqueous hydrochloric acid to form 1 mole of gaseous carbon dioxide one mole of liquid water and 1 mole of aqueous sodium chloride. Boom. Number 1 done. Okay, so we're going to use these particles that are over on the left-hand side just to make a general representation in particle format of what's going on in this chemical reaction. We'll use the red ones here for our sodium ions, and then we'll use this yellow one for our carbon, these blue ones for our oxygen. And because this is an aqueous solution, I might remember to put them as their individual ions dissociated in solution. My hydrochloric acid, we might use then for hydrochloric acid, this will represent our hydrogen, and this will represent our chlorine. Same thing, because hydrogen is a strong acid, we might want to represent it as completely dissociated. And we do need 2 of those. To match our coefficient in the balanced chemical equation. And then we'll need our carbon dioxide, which might look something like this. Our water, which might look something like this. And then again, our aqueous sodium chloride might look something like this, which I may leave dissociated because it is in solution here. And so here we've got a particle representation of what's going on in this chemical reaction. I'm just going to clean this up a little bit, make it look a little bit more like our equation in written format. I'm going to give us a little arrow in here to separate our reactants from our products. Put a few plus signs in here to represent our chemical equation in particle format. Okay, and the last part of this problem is asking us to explain in terms of bonding, it's important, whether the reaction describes a chemical or physical change. Now, if you're trying to describe whether or not this is a chemical or physical change based on sort of some macroscopic observations in the lab, obviously, if you had observed the formation of a gas after you'd mixed the hydrochloric acid and sodium carbonate together, it'd be a good indication that you had a chemical change sort of at the macroscopic level. But we're asked to describe it in terms of bonding. So I'm going to go back to my particulate diagram, sort of do a better job of explaining whether or not this is a chemical or physical change. So as I look in terms of the intramolecular bonds, in other words, the ionic and covalent bonds that happen here, we are breaking lots of those bonds. We're breaking some of the covalent bonds that exist within the polyatomic ion. We're breaking the covalent bonds that exist between the hydrochloric acid molecule, and we're reforming these new bonds that are creating new products with new identities. So if I were to describe this in terms of bonding, I might say something like, this is definitely a chemical change. And again, we're asked to describe in terms of bonding. So even though we got the formation of a gas, in terms of bonding, that wouldn't be sufficient. So you might want to say something along the lines of, bonds are broken and new bonds are formed. The identity of the products are different from the identity of the reactants. Boom.